This is the Hinterland Container Logistics Systems as Energy Systems lecture. My name is Rob Zuidwijk. So we'll discuss this topic looking at the following guiding questions. Why should one consider logistics systems as energy systems in the first place? And what are sample logistics challenges when you do so in support of zero-emission freight transportation? That's where this connection between logistics systems and energy systems comes up quite a lot. Well, why are we indeed talking about logistics systems as energy systems? Well, as said, this indeed has to do with the emergence of renewable energy as source to propel vehicles and other logistic systems, as at least in some cases, this, for example, could lead to certain restrictions. For example, the range of an electric truck is typically lower than the range of a fuel-based truck. And second, because this is an emerging technology, in a way, the infrastructure that we need to load, let's say, those vehicles when they are being operated also needs to be developed and chosen well. So let me maybe best to look at some particular examples that we are currently also working on and that in which we see very interesting aspects of how energy systems and logistics systems come together. Let's look indeed at this slide. On the right hand side, if we look at the pictures for a moment, we see a barge. And this barge contains containers that are being shipped from one place to the other. Now, there's one thing that you may note is that these containers are of different colors, but in principle they all look the same, right? But you see indeed a few brown containers, for instance, and they typically contain cargo. So the barge brings that cargo from one place to the other by means of containers, which are standardized loading units, but also some of these containers with this nice Z, this green Z on dark blue container. This is a ZEST container. This is not a container containing cargo. This container actually contains a battery. And this battery is actually used by the barge as a source of energy. So instead of having a fuel boarded, they board these containers as their source of energy to go from one place to the other. So this is an electric barge, which indeed uses batteries, which are of the same format as the cargo. Well, this can be very convenient. In the loading and offloading of cargo, they can also load and offload those batteries when they are empty or full. So they will, when you need a full battery, you will load yet another container, and that's then your battery. And if it's empty, you can offload it when needed. Now, this by itself already starts to define a logistics problem. Okay, because you will have a couple of those batteries on board to be able to travel for a certain distance. You will arrive at certain terminals to offload cargo, but when a container is empty or almost empty, you may decide to offload it and replace it by a full battery. But that full battery needs to be there, right? So what we will see is a problem where we ask ourselves the question of when should you load and offload those batteries, depending on how much energy there still is in. Where can I load those batteries to charge them with energy again, and for which barge should those be available? Especially when we have a network of barges, and that's not yet present. The example mentioned here is a pilot also incorporating Heineken, where they're looking at the possibility to make use of such a barge, but it's a point-to-point service to the Port of Rotterdam. But if you have a whole network of these barges, you will of course see that you need to decide on how to rotate those batteries, when to charge them, where to charge them, and when to make them available for another barge. This logistics problem is actually already known in some format. We already have containers themselves, which are indeed full with cargo, but they also will be emptied. When a full container arrives at its final destination, we do see that the container will be emptied it will be unloaded. The cargo will be taken from the container, and then we have an empty container which can be used again by another cargo owner to ship their cargo using that same container. That means that you need to think about, when I have containers going around the world, how do I make sure that I make proper use of those containers, and when somebody needs an empty container to put cargo in, do I have it available? This is known as the empty repositioning problem of containers, and actually we have seen quite recently, and still we see due to the COVID crisis, that actually repositioning containers in a proper way when there are disruptions can be a horrendous task. So we had major issues lately with the repositioning of empty containers because the COVID pandemic actually forced some new patterns of supply and demand of cargo, and thereby also a new demand and supply of empty containers. So what we can conclude is indeed that logistics systems may either be constrained or at least be specified and may depend on energy supply. On the other hand, those logistics challenges that can be that emerge from this connection between energy systems and logistics systems can also be a very interesting logistics problem by itself. And we've seen an example of the repositioning of battery containers. Thank you for your attention.